Welcome everyone to this video. Today we are going to discuss this problem from ISI 2024 entrance exam, which was conducted on May 12th. And this was the first problem of UGB. And it was given this limit, and it was also given that C is greater than 0. And we have to find all such values of T for which there is a finite real number C, and this equation holds. And we also have to find the corresponding values of C. So this was the first question of ISI 2024 BSTAT UGB examination. We are going to see how to work out with this problem and what to do if you are given this kind of problem. So those of you who are preparing for JE and JE Main and JE Advanced and examinations similar to that, you might already be sensing a pattern here. Like, okay, so the numerator is simply 1 to the power 1 by 3 plus 2 to the power 1 by 3 and all the way up to n to the power 1 by 3. So this is the numerator. And it's inside obviously limit n tends to infinity. But this gives us a sense that we have known Riemann sums, right? So we know that if we are given something like this, limit n tends to infinity, 1 upon n, summation I is equals to, let's say, 1 to n, and there is a function inside which is integrable, and we have the argument f of I by n. Then this limit is exactly equal to the Riemann sum 0 to 1 f of x dx. This is equal to the integral, right? This Riemann sum here is equal to the integral. So that's how the transformation works. Now, in order for this to work, we will first try to do some adjustments, so that we can convert it into that form. So your first instinct should be to write it in the summation form and see what it basically is. So we can write it like this: I equals to 1 to n, I to the power 1 by 3 divided by n to the power t. So let's just work with the limit, and we do not really want to indulge with c right now. So whatever the value will come, we will obviously consider that as c. So the value of the whole limit is c, right? So this would mean that we need n to the power 1 by 3 in the denominator, right? In order to make it a function looking like this one. So let's do that. Limit n tends to infinity. So let's take a n to the power 1 by 3 in the numerator. I also put the n to the power t here. And let's also put a n to the power 1 by 3 in the denominator. I equals to 1 to n. And this would give us I by n whole to the power 1 by 3, correct? Now, this thing, we also need a 1 by n, so let's just do it as well. We have 1 by n summation I equals to 1 to n I by n to the power 1 by 3 multiplied by, and you multiply everything together. So you multiply n, you multiply n to the power 1 by 3, and you divide by n to the power t. So this is our limit right now. So to simplify it further, this simply becomes limit n tends to infinity 1 upon n summation I equals to 1 to n I by n whole to the power 1 by 3, and you multiply it with n to the power 4 upon 3 my t minus t. Okay. So this is our limit. So what we do know is that the separate limit n tends to infinity 1 upon n I equals to 1 to n I by n whole to the power 1 by 3. This limit is finite because this is simply then equal to 0 to 1. The function, as you can see here, corresponding function would be fx equals to x to the power 1 by 3, right? So this should be like this because you substitute I by n for x. And the value of this is 1 by 1 plus 1 by 3, right? So this is basically 1 plus 1 upon 3, which if you do, you will get 3 upon 4. That should be the value. Now we want to investigate about this part, like what would happen for different values of t. So let's take some cases. Case 1. So case 1, let this be t is less than 4 by 3. When this happens, if t is less than 4 by 3, then you can see that 4 by 3 minus t is greater than 0. That means n to the power 4 by 3 minus t, this term basically has a positive power upon n, and if you take the limit of this term, it only ever grows. It never basically decreases, right? And we do know that the limit with it basically is a finite number, that is 3 by 4, right? So whenever you can show by bounding, Since this is a finite number, you can show that this limit should be basically greater than this limit. And if this limit here, the n to the power 4 by 3 minus t term, which basically bounds the entire sum, if this goes to infinity, the whole thing goes to infinity. So if t is less than 4 by 3, then our L basically goes to infinity, which is not what we want, right? So t less than 4 by 3 won't work. So let's take case 2. Case 2 should be t is equal to 4 by 3. Now, if t is equal to 4 by 3, then L should be equals to limit n tends to infinity 1 upon n summation I equals to 1 to n I by n whole to the power 1 by 3, and the term n to the power 4 by 3 minus t goes to 0, n to the power 0, which is 1, right? This, as we know, is 0 to 1, x to the power 1 by 3 dx, and you get the answer 3 upon 4. And for the cases where we have case 3, that t is, I think, greater, right? Yeah, t is greater than 4 by 3. In this cases, you get the same result. So let's say you have this whole thing here. So you have this whole thing here multiplied by n to the power 4 by 3 minus t, right? But now this term basically diverges because converges, because you see, like 4 by 3 minus t is the negative, and this means that this term is basically 1 by n to the power alpha for some alpha greater than 0, and this term will always go to 0. So in that case, what happens is L becomes 0, since limit n tends to infinity 1 upon n to the power, and if you write this like this, t minus 4 by 3 is 0, because t is greater than 4 by 3, right? So 1 upon n to the power something positive, this will go to 0, and this is what is going to dominate the other limit here, which is basically a finite number as n goes larger, right? It just goes to 3 by 4, but this one goes towards 0. So that would basically give you all the possible values here. So t is equal to 4 by 3 corresponds to c equals to 3 by 4, and also t greater than 4 by 3 corresponds to c equals to 0. That is the investigation that they have asked us to do about t and c, and this is the answer. Okay, so that completes the video. Please do subscribe the channel if you want to see more of this content, and also want to prepare for the upcoming ISI and CMI examinations or JEE Mains and JEE Advanced. So thank you again. Let me know if you have any other doubts in the comment section.